Once again, it is Joseph Lane here to teach you how to do maths. Oh my gosh, you must be so excited. You got to spend your day studying with me, and now you get to spend your evening studying with me. We are talking about scale factors coming into the 1.2 assessment for NCEA maths. Um, in doing this, I assume that you've already watched the video from the nice Scottish man where he talks about expanding scale factors and reducing scale factors. Okay, so if you haven't seen those already, go ahead down into the description, click on that link, and have a watch of those because it is important information and you should understand how that works before you move into this. What I want to explore in this, though, is how lengths of sides interact with the area of a shape. Okay, so I've got some example squares over on the left here. If I have 1 by 1 square, the area is, of course, 1 times 1. The area is 1 meter squared. So my sides are 1 and my area, my sides are 1 meter and my area is 1 meter squared, right? Let's look at the second one. Here we've got 2 by 2. And despite the fact that we've moved up by just 1 meter on both sides, we've actually increased the area by 3. So my sides are 2 meters and my area is 4 meters squared. The next is even more extreme, right? I've got sides of 3 meters each, 3 meters by 3 meters, and that actually ends up with 9 meters squared. And of course, 4 meters is a 16 meters squared shape, right? So despite the fact that at each point here we are incrementing up by 1 meter, here that increment is actually increasing the entire time. It is increasing exponentially, we say. So let's have a look at how that's going to interact when we are doing, get rid of this stuff, how that's going to react when we are doing scale factors. So if I increase the length by 2, and in this case I'm going from 1 to 2 meter sides, the change is actually times 2 squared. So I'm not increasing to 2, I'm multiplying by 2 squared. And if I go from 1 to 3, I'm not actually increasing by 2, I'm increasing by 3 squared. And if I'm increasing from 1 to 4, I'm actually increasing by 4 squared for my area. So we've got this whole setup that's actually changing as we go. Okay, let's have a look at an example where we're actually trying to figure out the area from the lengths that we've got. So here's an example where I have 2 similar rectangles, and I'm trying to find out the value of x and y. So in this case, x is obviously a length, and y is an area, okay? So the length is going to be the easy bit that we've already learned in the previous video, okay? I'm doing an expansion scale factor, right? An expansion scale factor so that I know I want my big number over my small number. So in this case, the similar lines that I can find are this one, this vertical right here, and this vertical right here. So my fraction setup is going to be 5 over 3. And I know that when I multiply this number here by 5 over 3, if I get 3 times 5 over 3, my result is going to be this number here. Yeah? So the same thing will work if I use this number here. I know that I've got 6 meters up here, and I want to find out what x is going to be. So I'm going to take my 6 meters, and I'm going to multiply that by my scale factor. Oops, excuse me. I almost put 5 over 5 there. 5 over 3. And the result is going to be 30 over 3, which is equal to 10. Yeah. So in this case, and Joseph is being on his worst behavior because, of course, we need to have our units in all of these examples. So we've done that math. And because I've drawn these rectangles to scale, we can actually count that out and make sure that it's definitely true. So in this case, I've got 1, 2, 3, 4, 5, 6 is my measurement over here. And on this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So we have figured out how to use the scale factor to find the length of x is equal to 10 meters. But it's not so easy to do that with the area, right? This area is previously very easy to work out, right? Area is base times height. So I'm going to switch back to my red marker. I know that my base is 3 and my height, my height is 3 and my base is 6. I know that 3 times 6 is, my technology isn't working with me, 18 meters squared. But we know for sure just looking at this, and I'll do the math for us. I'll do it in a different color so that we know that it's going to be wrong. 18 times 5 over 3 is not going to end up with our area of this rectangle here. That's just not going to be right. Everything's going to fall apart. We know this because we explored earlier that the area rises exponentially instead of just linearly, okay? So we need some other number to go in this space. And in this case, because we're multiplying meters squared, the value that we're going to use in this case is that scale factor squared, right? So this time, instead of doing 18 times 5 over 3, it's going to be 18 times 25 over 9. Now, this is pretty hard to do in your head, and in fact, I'm not going to do it in my head. What I'm going to do is use the magic of technology and pause this and use a calculator. So I've gone off to my calculator and I have learned that this value here is going to be 50 meters squared. 50 meters squared. Let's check to see if that answer is right. And again, I've drawn this to scale, so I know for certain that my answer is going to be right because I can count it out, right? So we figured out that the base in this case is 10 meters wide, right? So we know that the base is 10 meters, and we know that the height is 5 times 5, which means that our value for the area is 50 meters squared. So we've got 50 meters squared. It's been figured out in 2 different methods. And we could go through and you could pause it right now and you could count the area in here and you would know that that was definitely right. So when we're talking about the scale factor, we can use that to find our values when we are dealing with lengths. But if we're dealing with areas, we have to make sure that we're using the square. Because we're dealing with meters squared, we have to deal with the square of our scale factor. So this time I'm looking at something slightly different, right? This time I'm looking at a reducing similar shape. Yeah, this one's reducing. And in this case, I can see also that I actually don't know the length or the width of the second shape. All I've got is this area. So I can still set up an RFS, a reduction factor scale. And that's going to be my small over my big number. My small over my big number. Okay? In this case, we've got our small shape, which is this one right here, and we've got our big shape, which is this one right here. So it's going to be 24 over 54. Yeah, 24 over 54. Okay? We're going to reduce that to as small a fraction as we can possibly get. In this case, we can get it down to 4 over 9. So the scale factor that I found is 4 over 9. And we could check our work here. Let's check our work real quickly. I'm going to go 54 times 4 over 9. And we would expect for that value to give us 24 meters squared, right? Because I've come from here to there. I want it to give me 24 meters squared. I've pulled up my handy dandy calculator here. I'm going to go 54 times 4 divided by 9 equals, what do you know, 24 meters squared. So we've definitely figured out the scale factor, okay? But remember, this is the scale factor, or sorry, this is the reduce factor scale for an area. And when we're looking for these new values, we're not going to be looking for areas. We're going to be looking for lengths. So this time, as we're trying to figure out the value of A, we're going to be multiplying 6 times the scale factor, but we're going to have to do something to it. Remember, we're not changing from meters squared to meters squared. We're changing from meters to meters. So this time what we're going to have to do is we're going to have to take the square root because we're dealing with these meter values. We're dealing with unsquared units. So we need to unsquare the scale factor that we've got. So in this case, it's going to be 6 times 2 over 3. Right? Because the square root of 4 is 2 and the square root of 9 is 3. Okay? And that is going to be equal to, I'll pull up my calculator here one more time. Where'd it go? 6 times 2 divided by 3 is equal to 4. Right? 4 meters. And we can come back up to our scale drawing and see that indeed A is actually 1, 2, 3, 4 long. What about our value for 9? If I take 9, I want to multiply it by my reduced factor scale, which is 4 over 9. But again, in this case, I originally found out what that factor scale is going to be for a meter squared value. And I'm not dealing with meters squared anymore. I'm dealing with meters. So I want to find the square root of this. Excuse me, I was going to write 6 again. 9 times 2 over 3 is equal to 18, 6 meters. And when I go back over to my scale drawing, I can see 1, 2, 3, 4, 5, 6. Indeed, it has gone to 6 meters. So we can see the proportional increase and decrease of a shape by doing this. Now, this last example I'm going to show you is going to be a little bit harder. I'm going to have a little bit of extension for you. So have a wee check out on that as well. So here's our last example. Joseph and his wife Becky are designing their pool based on the pool cover they've already bought for the pool because they're silly and they don't know what they're doing. They like the dimensions of the pool that has been offered by a local man with a digger, but they want to increase the area of the pool to match their 175 meter squared cover. If they increase everything proportionally, what will be the new dimensions of the pool? So we are going to have to find the area of this portion of the pool that we're going to be covering, and then we're going to have to find the scale factor that's going to increase it to 175 meters squared. Okay, so that's going to tell us now we're going to be changing from our smallish pool to our larger pool. And in doing so, we'll figure out what the length is going to be. So it's a little bit confusing right now, but let's crack into it. Okay, first of all, I'm going to find the area of our pool as it stands now. It's going to be 6 times 25, right? Because it's base times height is equal to 150 meters squared. Okay, and now because I've got a smallish pool and I'm going to a larger pool, I'm going to be using my I don't know what happened there, EFS, which means that I'm going to have my big over my small. Yeah, so I've got my big number over my small number. In this case, the pool that we have is the small pool. So I want my small to be 150. And the large is going to be this new pool size that I've got, 175 meters squared. Oh, so when I reduce that fraction, both of these could be divided by 25. So that fraction is going to be 7 over 6. So our EFS is going to be 7 over 6. But remember, this is the area. We are working in meters squared as our units. We have meters squared as our units. So when we're trying to figure out the new dimensions of the pool, we're going to have to not use this, but use the square root of this. Okay, so I'm going to do another calculation over here. I want to find out what the length of this little thing there is going to be, right? So I'm going to take my 6 meters and I'm going to multiply it by my scale factor. Now hold on a second. Some of you will have already figured out that I made a mistake here. I'm not going to multiply it by my factor scale, am I? I'm going to multiply it by the square root of my factor scale. It's got to be the square root of my factor scale, because over here we were dealing with meters squared, and right here we're dealing with meters, so we have to bring it down. Okay, so when we do the math on that, look, I'm going to admit I am a very, very intelligent man, right? But I'm not so intelligent to be able to work this out. So what I'm going to do is I'm going to use my handy dandy calculator right here. Square root of 7 over 6 times 6 is going to be 6.48. We'll go with 6.48. 6.48 meters squared to 2 decimal places. Oops, I put meters squared. That's not what I meant, is that? 6.48 meters. So in our new pool, this value right here is going to be 6.48. Okay, what about the value of this one right here? It's going to be basically the same process, right? I'm going to take 25 and I'm going to multiply it by the square root of my scale factor, which is going to be equal to, again, I don't know this well enough, so I'm going to go clear everything. 7 divided by 6. Find the square root of that number, multiply it by 25, and what do you know? That actually comes out to kind of a nice number. 27.00 meters, 2 decimal places. Is that actually accurate? Let me just double check my calculator. Yeah, that is accurate. 27 meters. So in my new pool, this side is going to be 6.48. Oops, that's an ugly 8. And this side is going to be 20. I can get rid of that. 27. Yep. Brilliant. You're amazing. Now, we're going to do one more thing. If that's all, if you want to stop there and practice some of the stuff on your own, you can go ahead and look at some of the worksheets attached. Give those a go. But I want to find out what scale factor number I'd use to change my pool from its current volume, the volume current, to the volume new. So I want you to, if you want to do this extra little exercise and think about it, I want you to think about what's going to be happening. What number are we going to be multiplying by to get the volume of our new pool? Okay, that's enough thinking. I'm going to walk through it with you real quickly. Okay. Oh, man, I don't know why I don't want you to zoom. I want you to move. Oh, gosh. Okay. How am I going to do this? I'll pause you right here. So the first thing we need to do is find the volume of our current pool. Okay, so the volume of our current pool is going to be the surface. Oh, gross. Automatically got it. Okay, is going to be the surface area of this here times the depth. Okay, so we want the surface area of that trapezoid times the depth. And in order to get that, what we're going to do is 1.5 plus 3 divided by 2 times 25 times 6. Okay, so have a look at your cheat sheet. So you'll have this on there. Trapezoid, trapezoid prism is going to be done like this, and then when we do all of our calculations, which I can do right here, 1.5 plus 3 is equal to 4.5 divided by 2 is equal to 2.25 times 6 times 25. We are going to come out with 337.5 meters cubed. 337.5 meters cubed. So that is our current volume. Now, we learned earlier that our scale factor, when we're doing areas, our scale factor for areas is going to be 7/6. And we learned that our scale factor for just lengths is going to be the square root of 7/6. So what is the scale factor of our volume going to be? What's the square factor, the scale factor of our volume going to be? Well, we can think about it in terms of the units that we are working with. The units for our lengths are meters. The units for our area are meters squared. And the units for our volume are meters cubed. So this is going to be kind of hard to understand, I think, but we need this number here cubed. We need that number here cubed. And so what we're going to do, instead of, the way that we're going to do it is we're going to take our square root of 7/6, and we're going to raise that whole thing to the third. So if we want to know what the volume of our new pool is going to be, we're going to take 337.5 meters cubed, like we've got right here, and we're going to multiply that by the scale factor that we have just figured out. 7/6 all to the power of 3 is going to be equal to, and look, I know, you think I'm a god, you think I'm incredible. I've seen the looks on all of your faces as I teach up on the up at the front of the classroom, how impressed you are with me. But again, I'm just a mere mortal, just a mere mortal. So I'm going to have to use a calculator to figure this out as well. And you know what? Joseph has already done it wrong because, we all make mistakes. Mistakes are easily solved. You just got to do it again. And then we're going to do to the power of 3. And we're going to get that. And we're going to multiply it by, and remind me what the number is, 337.5. 337.5 equals 425.30. 425.30, 25.30 meters cubed to decimal places. And if I wanted to, I could go through and do all of those calculations to figure out what the lengths of each of these were, and then do this calculation again to come up with this number right here. But instead, I'm just using the scale factor to the power of 3. Okay, so that's I hope this helped. I know that this is a confusing concept and it is actually difficult to come across. So if this did help, let me know. If it didn't help, let me know. Hopefully I can give some more information to you so that this test is the easiest thing you've ever done in your life. Yep, cool. Have a good evening. Take care of yourself. I don't know. Like and subscribe. Sign up to my Patreon. I don't know. Whatever. Do those things. Bye.